Next, we come to look at another theorem, which is called factor theorem. It's very similar to remainder theorem, or you can say it's derived from remainder theorem as well. So see what's happening. And then when you are talking about remainder theorem, we did mention that when you have fx divided by x minus a, then the remainder is equal to fa. The reason is because when you rewrite fx by division algorithm, it's x minus a having a quotient as well as a remainder. But what if we don't have the remainder? You will see that fx will be presented as x minus a times the quotient, or in other words, x minus a becomes a factor. So that's why in this situation, when you have 0 as a remainder, that means fa is 0, then you can say that x minus a is a factor of fx. Similarly, now we have, okay, this one is n over m. So what does that mean? So when you have fx divided by mx minus n, and then you can present it as fx is equal to mx minus n, a quotient as well as a remainder. And this remainder can be obtained by f n over m. So just in case it is equal to 0, that means this term is it disappears. And then as a result, fx will be just mx minus n times qx, which means it is a factor of fx. So can you correlate factor theorem with remainder theorem now? Somehow you can say it's a special case when you have remainder equal to 0, which means that you have a factor in the division. So now it becomes, the factor theorem becomes a method for us to check whether the following items is a factor of the polynomial or not. For example, like in the coming example, when you have fx divided by x plus 2, and you want to check whether it's a factor, and then so it's simply substitution of this one, will be substitution of x minus 2. So f minus 2 would be, when you do the calculation patiently, minus 2 times minus 2 squared, minus 5 times minus 2, plus 6, which gives you a 0. When it is a 0, which means no remainder, and then that's why we can conclude that x plus 2 is a factor. You can quickly check number 2 is not a factor because it's not 0. Maybe I also do it to you here. When you check this one, you're doing substitution of x is 4, which gives you f4. The calculation will be 4 cubed, 2 or 4 squared, minus 5, 4, and plus 6, finally is 18. So because it's not 0, so that's why you can say x minus 4 is not a factor. So it's quite easy, right? And now we come to see the importance of having factor in our further study. The following example shows you another function called g, and you have to show that fx plus 1 is a factor, and lastly, to factorize it. Okay, there are two steps. One is called show that. So can you understand what's the meaning of show that? Not easy to understand, right? So it is a proof in the question asking you to find a way to explain why x plus 1 is a factor. In other words, that means you're going to show me that g minus 1 is 0. Repeat, you have to show me that it's 0 so that you obtain a factor. So here it comes the answer. Part A, so you check for g minus 1, which gives you 2 minus 1 cubed, 9 minus 1 squared, 13 times minus 1, and plus 6. By calculator, you get the 0. In this case, it means that x plus 1, bear in mind that substitution of minus 1 means you are talking about x plus 1 in the division, is a factor now. The use of factor, you can say, is for factorization because it ensures that the division is so-called properly, it can be done properly, and there is no remainder. And then that's why you can do factorization afterward, which is you can't avoid having the long division over there, which is called 2x cubed, 9 squared, 13x plus 6 divided by now is called x plus 1. Once again, pause your video for a few minutes and complete the division by yourselves. Finish? If no, pause your video again, or else you can start listening to the video. So the division I put on the right hand side, and bear in mind that the remainder should be 0, nothing at the end, because you're talking about factor. And now you need to use division algorithm to present the answer as follows after the long division. Maybe I put in red on the right hand side. So your gx now can be rewritten as you have factor x plus 1, and you have the quotient called 2x squared plus 7x plus 6. No remainder, so that's why there's nothing to add at the end. And then finally, you have to also check that whether the latter expression, the quadratic one, can be factorized or not by cross method. And finally, you see that it can be further factorized as x plus 2 and 2x plus 3. So this is the meaning of factorization in the question. Next, we jump to example 24. It is a hard question because it carries two important concepts. One is this time I'm not asking you to solve. I'm not asking you to factorize, but you are asked to solve the equation compared to your previous example. The other situation is I ask you to factorize it directly without giving you any hints. What do you mean by without any hints? Can you see that compared to your previous example, which is example, what's that? Example 20, right? And then in that example, I will tell you show that blah, blah, blah is a factor. And it is a very important step for you to do some proof as well as you know how to start your division. But in example 24, it directly asks you to factorize the expression without any hint. So shall I start with x plus 1, x minus 1, x plus 2, x minus 2, etc.? Question marks, right? And then now you have to note there is a technique to guess a factor. So that's why I said it's a little bit hard because you are going to guess it. So how do we do it? It would be look at the constant term at the end. And then in which you have to see that minus 2 can be written as minus 1 times 2. It can be minus 2 times 1. It can be any other thing else. No, that's all. So that's why 1, 2, 3, 4, they may be the choices for you to start the question and check for the factor. What do I mean? I mean is when you have to check this one, for example, g minus 1, you can check for minus 1 cube minus negative 1 square minus negative 1 and minus 2. And calculation is minus 1, minus 1 plus 1 minus 2. So that's why it's minus 3 is not 0. It fell, sorry. You can also check for 2. Maybe I'll check it for you with you here. G2 is 2 cubed minus 2 squared minus 2 minus 2, which gives you 8 minus 4 minus 2 minus 2. Oh, that's good. It's 0. So it means that in this very quick check, you will see that x minus 2 is a factor. That's our proper start. And then once we have a start, then now we can start doing the calculation as follow, or the answer as follow. G2, after you check, remember, this is all your trial, all your rough work, is 2 cubed minus 2 squared minus 2 minus 2 is 0. And that's why x minus 2 is a factor. Okay, we rewrite everything we did check on the right-hand side. And afterward, factorize means that after you've got a factor, then you can do the division accordingly. And now you, again, pause your video, try to do it for a few minutes, and get the answer. Hopefully you finish the division, and finally you can see that gx is first factor, x minus 2, and multiply to the quotient, which is called x squared plus x plus 1, and that's factorization. Moving on to part B, in which you are going to solve it, so that's why you better start with the proper sentence first, which gives you part B is called x minus 2, x squared plus x plus 1 equals 0. And each bracket will be 0. Okay, you have the following. Okay, first one is quite easy. You can get x is 2 directly. But while the second one, you can see that after using calculator, you find that there's an error, which means there is no real root of this equation. But in order to present it very precisely in a math language, we need to check for the delta. The delta will be 1 squared minus 4 times 1 times 1. Now repeat, you need to check for delta, show that delta is negative in order to explain why the equation carries no real roots. Is minus 3 less than 0? And you say that it has no real roots. And as a result, finally, you only have one answer, which is equal to 2. Finally, we come to a very hard question, example 27. So let's take a look. The question tells you that there is a polynomial fx. Again, it is unknown. Divided by x minus 1, remainder is 2. Divided by x plus 1, remainder is 4. But the most important thing, or the most weird thing, is you are asked to find a remainder where it is divided by x minus 1, x plus 1. And then so it's very difficult to start the question because you don't know what is fx. You can't do the division. And then the most important thing, or the concept as follow, would be, again, by division algorithm. The situation is because you don't know fx, and then but I need it for applying remainder theorem or whatever way, substitution, etc. And then as a result is now talking about divided by x minus 1, x plus 1. I have a qx, and I have a remainder. But the problem comes when you write out here, because this time is a little bit different. Can you see that when you are doing division of x minus 1 plus 1, when you expand it, it's x squared minus 1, which is a degree 2 polynomial. So it means that when you are talking about the remainder, it's no longer, or it's not necessarily just a constant, but it may be something about x, it may be something about constant. So that's why we have a special expression to present it, which is the remainder can be something about xe, so we call ax, as we don't know how many x are there. It may be 1, it may be 2, it may be minus 3, etc. There is also a constant possible over there. It may be 2, it may be minus 7, etc. So that's why the remainder is ax plus b. So in order to start the question, you have to keep this concept very clearly, very solidly in your mind. And in your answer, you immediately apply the concept and saying that, now I know fx is equal to x minus 1, x plus 1, quotient qx, with the remainder called ax plus b. The question will be very different because now when you're asked to find the remainder, that means you're actually finding a and b so that you can present the remainder very precisely. The importance of division algorithm appears once again here, that it helps you to write a formula of fx, even though this one is very scary. But yet you can still use it for substitution. And now we follow the color, green and yellow, to start the question. Green one. Okay, when it's divided by x plus 1, remainder is 2. So that's why we have f1 is 2, which gives you, okay, 1 minus 1, 1 plus 1. Again, q1, we don't know what is it. We just leave it there. And you have a times 1 plus b equal to 2. The very special thing, you will see that there should be 0 in the in the calculation. So when it's 0, that means the whole thing goes away, which gives you a plus b equal to 2, which is equation 1. Turning to yellow, you have divided by x plus 1, giving you remainder is 4. So that's why it should be f minus 1 equal to 4 as a start. And now you have minus 1 minus 1, minus 1 plus 1, q minus 1 equal, not yet equal, plus a times minus 1 plus b equal 4. Very long, but once again, there is a 0, so that the whole expression cancelled. Finally, you have minus a plus b equal to 4, which is equation 2. And finally, you have, by solving equations, you get a is minus 1 and b is 3. Okay, let me double check it. Yes, correct. And as a result, ax plus b is the format of the remainder. And I'm now putting back into the framework, the format, and the remainder now I know is minus x plus 3. It's hard, right? But hopefully the presentation here in this example tells you how you apply the concept of using division algorithm and the concept Why we can say the remainder it is in terms of ax plus b? Because it is degree 1.